Hey guys, what's up? In our last tutorial, we learned how to create this a neural network which looks like this, a perceptron, and how to train it with some sample values and how to use your own custom inputs to see how the network is performing. Now, while doing so, if you remembered, if we run this, let's run this first and we'll see. So here it is. You can see the error when we are printing this one. This is the error and it's in a 16% error. So 16% error is very high, and for this simple network structure 16% error is too much. It's not something that we want. So let's try this with some inputs and see. You see, if one for one on one, it should give me 0, and it's almost giving me 0.56, which is almost very near to 50. It's not a good network. It's not well mapped. So let me show you what happened wrong there. I copied this line from this line. I changed this to output. I changed this to output layer activation, but I forgot this to change to output. So it's remained like this, whereas it has to be output. And now if we run this, the error is almost now 3%. Let's check this with our input again, and yes, for 1 and 1 it should be 0, and it's up very close to 0. And if we set 0, 0, it's again very close to 0, which is 0, 0. And if we set 1 and 0, it's very close to 1, and again 0, 1, it's very close to 1. So it's performing much better now, because previously it should have been output, because we're applying activation to the output layer and assigning it to the output, but instead we made a mistake and we created this, assigned it to the hidden layer. So one of my viewers pointed out to me in the comments. Thanks for that. Now we can make these kind of mistake anytime. So how can we know that the network that we have created is actually the network we have planned? Like means the network that we planned is something like this, but while creating the network we built something which is structured in a different way. That is obviously by mistake. Now how to avoid that? While Google was building its own neural network model called Inception, they are also facing the same issue. So they created another tool to debug that. It's called Tensorboard, and it's like a magic. So whenever we are creating a network using the we are coding a network, and we want to visualize how the network is formed actually, we can actually use Tensorboard to see how the network is actually looking. So without wasting our time, let's start with the Tensorboard tutorial. Okay, this is the same code that we wrote in our previous tutorial. I just made the font size a little bit bigger so that it's visible to everyone. Now let's start with Tensorboard. There are two basic concepts in Tensorboard. One is summary writer and scope. So first we will talk about summary writer and summary. What summary writer does, it actually mark that, let's say we want to know the value of output and value of the inputs and the targets, or inputs and the outputs, every time we run the network with some input value. So what we can do, one thing we can do is we can print this output like this. So it will now give the output value, and we can have the another variable called out, and we can print it here along with error. Like the inputs also, for the inputs we can directly print the inputs, and like that. But if we do this, let's try to do this and see what we get. We can see these are the values we are getting. Just wait a little bit more. Okay, so these are the values we are getting for the outputs. You can see the output value is looking like something like this. This is not something that we can understand, because we cannot go by watching this each and every outputs in the terminal and conclude any decision that it's good or bad. We need to plot this, and then we can understand if error is decreasing, how fast it's decreasing, and if it's already getting saturated or not. So these things, if we don't plot it, we won't be able to understand. So what this TensorBlow summary writer does, we can directly mark these any of the variables as our to our summary. We'll write those value of those variable in a file, and the TensorBoard program will take those value from the file and it will plot it in a browser. So let's write some summaries for our network to understand how it's looking. I want to write the values of the weights and output weights. It means it will give all the values of these weights and these weights. To write it in a TensorBoard summary file, we need to call this summary module. So it is, let's say for this one, we want to write df dot summary dot. Now there are two kinds of basic summaries: histogram, one is scalar. So what are the difference between these two? Let me explain. Let's say I want to know the output, or I want to know the errors for each run, which is this one, which is a single value, and we can directly plot it in a xy graph. But let's say we want to know the values of these weights. So this is an entire matrix of weight connections. So there is no point of tracking the values of one single connection weight, because let's say for this picture we can see there are 9 connections, but let's say we have a hidden layer which has 1000 neurons. Then these it will be 3000 number of input connections here. So there is no, we cannot go each and every connection and check if it is, what is the value, and what is, there is no point of checking one single connection. What we will be interested in to see how most of the weights are distributed. So is all the weights are distributed in some portion, or it's distributed in various region. We will be interested in that thing. So for that we would be needing the histogram, and for the error we will need only one value, so we can directly plot it in a xy graph. So this weights matrix is a matrix, and we would be interested in the histogram of this. So we'll be diagramming the histogram, and it takes the name you want to put for this plot. Let's name it input, or name it weights, whatever it is, weights, and or you can name it weight 1. Let's copy this, and I want to write the weights for this one also. And oh sorry, here there I have to pass the weights also. So this will be this one, values. Its values are this. I don't need this. And here I want to the second weight, and the values will be output weights. Okay, this will be names. Okay, oh sorry, this will be value. Okay, so we have written the summary for the output weights and the hidden weights, and we will also want to plot the error. Dot summary dot scalar, and now again name, which I'll be calling it error, and the value is error. Value, actually what you can do is instead of calling it using name parameter, you can directly supply the value and then the name, which is you can also do it like this instead of using the named parameter. Okay, so one more thing is to print the error, we can't print this error. We actually have to print the cost, which is the part of the network. This is just a value, so sorry for that. Let's move it, and the error basically is the cost here. So let's print the cost, and place the cost here. This is the error because this is the value after we evaluate in the session, but the summary writer has to mark the nodes in the network, which is the cost which is evaluating to the error. So now we have marked everything. We have to tell the session that we want to write summary in a file. So what we will do, we will merge all the marked summaries, tf dot summary dot merge all, and we will call it merge summary, mergd merge summary. Merge summary equals this, and now we will write it in a file. First create the file name where we want to write, equals, and like I said, let's summary log, or let it be summary underscore log, and we can actually give file name like this, but the problem will be every time we run it, for initial run it will be good, but if we run it again, it will write it on the same file with the new values of the recent run, so the previous value will also be there. So what will happen, there will be a multiple overlaps of the data, so we don't want that. We want a clean summary for every run. For each time we run it, we want it to run a different file, a new file. So what we are going to do here is we are going to append timestamp, so that each time we run it, it will be a new file instead of a same file. So what we are going to do, we have to import this date time. So let's import date time, and here we'll add date time dot date time. Now we have the time, but we want to format it in a different way, because the date time might have some characters that the file name won't take, so we will format it in this way, dot str string format time, and we are going to use our year, month, day, hour, minute, second, and it will be separated with hyphens and 2 hyphens in between. So let me just copy it from here. So it will give a different file name every time we run it. Now we have the file name, we want to write the summary in that file. Let's create the writer, equals tf dot summary dot file writer. Now you will write it in this file. This is the log directory, and we have to give the graph of this session. Graph is the actual diagram of the network. We also have to provide that, so let's provide that. It will show us the entire network, how it is built. Graph. Now we have the writer ready. What we have to do, we have to run this merge summary in our session run dot run. So summary output, by the way I just removed the output because we don't need that. And now that we are writing it in our Tensorboard, we don't need this print also. Let's remove this print, and instead of print we will write the writer. Use that writer to write that this summary output in the file. And we also have to provide another thing is the counter. What is the current iteration is going on. We can use this, so it will show what is the current iteration and what is the value of all the variables that we are writing in the summary. Now it will write it with that one, and voila, we are done. Now we can easily run this code and it will write it in a summary, and we can see it in a Tensorboard. Let's stop this first. You will see that it will create a summary log folder in our current directory. Okay, something histogram got for an unexpected keyword value. Okay, Okay, this will be values. Okay, let's run this again. Okay, another error, which is scalar. Okay, I did one mistake here. It will be first the name, then the variable. So that is why I most of the time I use name parameter. So if we do it like this, name and then values, then we can uh, even if we place the values first and the names after that, it will still work. But if we don't use the named parameter, it has to be in the same order that it is defined in the function definition. So it has to be named the first, then the values. So let's try again. Another file writer object not callable, 1 minute. Sorry, so here I made a mistake. It will be add summary. So instead of the writer has a method called add summary and we have to supply it there. So it's running, I hope. Okay, done. And we can see that our summary log is here and it has a run folder here and its events, all the other whatever it is. Let's just check it. So to run the tensor board, we have to type, let's clear first, tensor board, and we have to specify the log directory equals dot slash. If we specify only this log directory, it will automatically go each and every run folder and it will recover the whatever runs we have did till now. Y log underscore summary log, and let's run this. Okay, so it seems the tensor board that was installed in my system was not compatible with Python 3. Let me try to install it again and see. I hope it works, or otherwise I have to go back to Python 2 again. And here we go. Okay, so bingo, we have our web address and this is the address we have to use in our browser to see the tensor board. Let's copy this and just put it here. So here we have our data and these are the two runs we did. One of them was failed, so we can check this is the file name format, which is year first, then month, then day, and the time format. I don't know what the second is, why the second is like this. Anyway, so our data is the error. The error initially was like this, then it's slightly saturated at the a little bit at this point till 1500 steps. After 1500 steps it's started dropping again, and at 3 at almost 400 is very low, less than 1%, and that's very good.